Hi, my name is Kat, and today I'm going to be talking about my UV nail gel glue curing experiment. So essentially, gel nail glue is an adhesive substance that is initially a liquid, typically stored in an opaque bottle. And when this liquid is exposed to strong UV light rays, it encounters a phase change and hardens into a solid. This reaction occurs because gel nail glue contains monomers and oligomers. The glue also contains photoinitiators, which are compounds that react when exposed to UV light rays, which makes the full curation and the phase change in general possible. So I'm just going to be talking more about that and the outcomes of it all. So what is this project? Essentially, I created a procedure that is intended to observe and measure the phase change of UV curable nail glue throughout the entire curing process. And after collecting my data, I'm going to use it to evaluate the entirety of the thermodynamic process of this phase change. Why did I choose this project? So, first off, I've been doing my own gel nails for a few years now. And when I say gel nails, I just mean ones that use UV rays to go from a liquid to a solid to adhere them to your nail. So on top of this, I also started a nonprofit where I make press-on gel nail sets and I donate them to women's shelters and domestic abuse support centers, just to give them a way to express themselves. So obviously that makes this topic very close to my heart, and it is also a very interesting one to learn about. To start off with the procedure, we need to touch on the materials that are needed. So the first thing is going to be what the whole experiment is about, and it's the UV curable nail glue. I chose to use my favorite kind, which is the Gaoi brand. You also need a UV LED lamp to cure them, a thermocouple, which is intended to measure the surface temperature, glass slides to put the glue on, a timer just to time the whole experiment, and an analytical balance to measure the various mass changes. So for step one, we have everything preliminary. So we'll start with the setup, which is shown in the picture to the right. So the first thing we're going to do is plug in the UV lamp, which is the pink circled section in the photo. So essentially it's just plugged in so that it stays on, just so the battery doesn't die. Then we're going to use this little red cord connecting the green multimeter to the yellow circled thermocouple. So we just plug them into each other, make sure it's plugged in the correct way or the temperature is going to go down instead of up. Then we turn on the multimeter and set it to measure the temperature. Then we insert the thermocouple all the way into the UV lamp to where the end of the thermocouple tip is touching the back of the lamp. Then we make sure we have a timer near, which is the part circled in purple, just so we're all ready for when the experiment begins so that we can keep track of our time, because we do have to note that. Then we need an analytical balance just to take all of the preliminary measurements and also to measure again after the experiment is completed. And then we just have a spot for the control sample, which is pictured in orange, for it to rest outside of the UV lamp so you can see it and collect data on it at the same time that you do with the ones in the UV lamp. Then for our preliminary measurements, we're going to need to measure the mass of an empty slide in grams. We're going to need to take the mass of a slide with a patch of about 1 millimeter by 2 millimeter of the Gaoi gel nail glue in grams. And I chose that size because it's roughly the size of an average human nail. And then lastly, we're just going to need to take the initial temperature of the inside of the lamp, which is just reading the temperature given from the multimeter, which is going to be in degrees Fahrenheit, but we'll later convert it into Celsius. And for further clarification, you can focus on the picture to the right. It shows everything that you need and how it's all set up. So before we continue on with the procedure, I feel that there is a really important note to give. So the nail glue that we're using for this experiment absolutely must contain photoinitiators, monomers, and oligomers. These are the molecules that work together and are responsible for the phase change that we're observing, and that is the whole point of this experiment. So if the samples don't have these things, they will not cure, and will just make this overall unsuccessful. So for a little background on that, a photoinitiator is a molecule that becomes reactive when it's exposed to radiation, and the radiation it's being exposed to in this case is the UV rays from the lamp. And it shows it on the back of the bottle, but the photoinitiators included in this glue are the hydroxycloexyl phenylketone, the ethyl trimethylbenzoyl phenylphosphonate, and then monomers are a group of small reactant molecules that are primary reactants that polymerize when they're activated by free radicals. So essentially, they provide the fluidity to the liquid, and they make it easy to apply, and they allow for rapid reaction because of their small size and very high reactivity. So they're good at controlling the curing speed and affect the final hardness and brittleness. In this case, the monomers are HEMA, hydroxypropyl methacrylate, and isobornyl acrylate. And the last one is the oligomers, and those are short monomer chains that are already polymerized, and they basically act as a bridge between the monomers and full polymers. The function of them is basically just providing viscosity or the thickness to the gel. They control shrinkage and cracking during the curing process, and they add the toughness and flexibility to the final product. And there's only one in this specific glue, and that is the dihema trimethylhexyl dicarbamate. So we just need to keep this in mind for our glue. So with that being said, we can move on to step 2, which is preparing our samples. So the first sample we need to prepare is the control sample. So we place the same small amount of gel glue onto a glass slide, which we're sticking to about 1 millimeter to 2 millimeters. And we're going to make sure to weigh this slide both before we add the glue and after we add the glue. We just do this using our analytical balance. Then we record the initial temperature, the physical state, and the appearance in just an Excel sheet. Then we make sure to place the slide outside of the UV lamp where we can continue to observe it, but it isn't being affected by the strong UV rays from the lamp. Then we move on to preparing our cured samples. So we're going to place the same small amount of gel glue onto 4 glass slides. And we're doing this 4 times just to ensure accuracy in case any sort of error occurs with any of our samples. Then we do the same thing of weighing the slides before and after adding the gel glue. And then we place each of these samples into the UV lamp. And we're going to try to make sure that they're equally as far towards the back so they get roughly the same amount of rays. Obviously, it's going to vary a little bit, but just try to make it as equal as possible. Step 3 is beginning our data collection. So our first step of this is just turning on the UV lamp to the normal power setting and starting your timer. You want to make sure that they're pretty synced up as well as possible. Then you're going to observe and record the temperature, physical state, and appearance every 10 seconds for the first 3 minutes. Then once you hit the 3-minute mark, you're going to record the same data every 5 minutes until you've hit a total of 30 minutes. Then after that, you're going to weigh the samples, again using the analytical balance. Here is just a video showing our setup. As you can see, everything is hooked up in the picture from the slide before, where our thermocouple is hooked up to a multimeter, which is measuring the temperature of inside of the lamp, and our control sample is right next to it to also be observed. So this is the raw data that I collected from this experiment. It's an average of the 4 samples. So as you can see, around 70 seconds was when the phase change began because the liquid got a little bit stickier, meaning that it was moving more towards being a solid. And then 90 seconds was when it really switched to being a solid. And then the phase change was complete around 120 seconds because it became a complete solid with no stickiness. So there was no liquidity left in any of the samples. It also lost some bubbles, as you can see, because it went from some bubbles to minimal bubbles. And this makes sense because on the packaging it said that each sample should take about 60 seconds to cure, like for each nail. And we used a little bit thicker of a layer than you usually would with a nail, so it's a little bit above 60 seconds, which makes great theoretical sense considering the 60 seconds that it says on the bottle to cure. So this blue chart is the raw data that I collected for the control sample. And as you can see, the only thing that changed is the time, because obviously the time has to go up, but the temperature, the physical state, and the appearance stayed exactly the same, which is theoretically exactly what was supposed to happen. So that is really good, because since nothing was changing, there were no variables that were altered with, it should be the exact same. And the pink one below is just comparing the initial and final masses, and they're relatively similar, enough to chalk up to just human error, or just analytical balance errors. So you can see that theoretically the mass should not change between the initial and final state of it. So the picture that's more purple on the right is just a picture inside of the UV lamp of all the samples, and you can see the thermocouple on the far left. And the picture on the left is the same picture, but the vibrance is turned down and the brightness is turned up, so it just gives like a better depiction of it, and you can see how the glue actually looks more like a solid after it was cured. So moving on to the mathematics behind this whole curing process, I used my collected data, and the first thing I did here on the right is I calculated the enthalpy change, or delta H, and you can follow the steps that I did that in the slide, and then I used that along with the literature assumption value of delta S to calculate using the Gibbs free energy equation to solve for delta G. And we're not going to dive too deep into it now, because we'll see in a minute how these values come into play and what they really mean and what they are able to thermodynamically prove for the situation. I broke down the thermodynamic process into a few parts because it's a lot to examine, and the first part is the initiation by UV light. Here's when the photoinitiator molecules absorb the energy from the light that's provided by the UV lamp when the gel is exposed to the UV light. And this is when the energy absorption excites the photoinitiators, which cause them to break apart into free radicals, which is a huge part of the process. So we move on to the polymerization reactions, which is when those free radicals actually come into play and react with the monomers, setting off a chain reaction. And this is what causes the rapid formation of polymer change, which is basically what converts the liquid into a solid and is the whole phase change. And this reaction is known as a free radical polymerization, which happens in three main steps, which are initiation, propagation, and termination. And in our experiment, we really see the first two steps firsthand here. So the next part is just broadly the whole thermodynamic perspective. So we learned that this process is exothermic, which just means that heat is being released, which actually makes a lot of sense, because if you've ever gotten gel nails done, you know that sometimes when the glue is curing to your nail beds, it actually can kind of hurt sometimes. And you occasionally have to like pull your hand out of the lamp and put it back in because it hurts. So Gibbs free energy, or delta G, is positive. So that means that the reaction is not technically thermodynamically spontaneous on its own, but it does become so with photon energy that is given from the UV light. So that basically just means that this process is photochemically driven and is not purely thermal, which was not originally expected, but it does make sense. So we really see here that this system transitions from a higher energy disordered state, which was when it was a liquid before curing, to a lower, more ordered state, which is after it cured when it was a polymer, and this overall just makes it more thermodynamically stable. So the last part of the whole thermodynamic process of this reaction that I felt was important to touch on is the changes in both the enthalpy and entropy. So for enthalpy, or delta H, what we calculated does confirm that this reaction is exothermic, but it is relatively mild, and that's basically only because of the small size of our sample, and I chose to keep it that small because I wanted to simulate what it was like for a real human nail. But Theoretically, if we chose to do this again with a more concentrated or larger sample, the heat release would be significantly more pronounced. For entropy, or delta S, we know that it's decreasing because the monomers organize from having less structure when it was a liquid to a lot more structured solid, meaning that there's a lot less randomness. And despite this drop, the exothermic nature still proves Gibbs' free energy equation. So how do our results actually prove thermodynamics? So first, one observation that we saw is that the temperature increases during UV exposure. So that really goes to show that this reaction is truly exothermic. Another thing we saw is how the gel glue in our control sample will remain a liquid without UV light activation. So this just shows that the whole reaction is light dependent, which just means that it's photoinitiated. And another observation we saw was that there was no mass loss throughout the whole thing. And that proves that this reaction is not evaporation or something of that sort, but it is actually just a chemical bonding. From this, there are a few conclusions that we could draw. The first one is that gel nail glue is triggered by UV light. We can also say that the reaction is fully exothermic, and it's also essentially just a chemical polymerization. And the last conclusion is that UV conditions are thermodynamically favorable because without those UV conditions, the phase change would not ever take place. In summary, we know that UV light doesn't trigger a fully thermodynamic reaction, but a photochemical one. We know that free radicals start the polymerization process, and that exothermic heat release drives the whole reaction. And we also know that the liquid turns to solid due to molecular cross-linking. And here are all of my references for this project, and thank you so much for listening.